This video will cover Chapter 3. So first, continuous compound interest. So A equals P times E to the RT. So get a question like this: how long will it take for an investment to go from 7,000 to 10,000 at 4%? So we use our equation, and so here we got that 10,000 is going to equal 7,000 e to the 0.04 t. Well, the opposite of multiplying is dividing, so we can divide by 7,000. You can divide this by 7,000. And so we get 10 over 7 equals E, 0.04 t. And then the opposite of E is natural log. So we'll do the natural log of both sides. And so we get the natural log of 10 over 7 is going to equal 0.04 t. And then the opposite of multiplying is to divide. So we'll divide by 0.04. And we can get our answer that t is going to be 8.92 years. So just under 9 years for us to get to that goal. All right. So in terms of then derivatives. So it ends up that the derivative of e to the x is just e to the x. So if I had this, f of x equals 4e to the x minus 7x squared plus 21x plus 2. And I want to know what's the derivative. So f prime x, well, this is going to be 4e to the x minus 14x plus 21. And then the derivative of natural log is going to be 1 over x. And so again, in terms of f of x equals 8e to the x plus 7 ln x. Then my derivative is going to be 8e to the x plus 7 over x. Okay. All right. Well, let's see. Other forms they mention in this chapter is these ones, d dx of b to the x is going to be b to the x natural log of b, and then the derivative of log base b of x is 1 over ln b 1 over x. Right? So let's solve this one. So suppose we want to invest $10,000 at 7.5% compounded continuously And we want to find the instantaneous rate of change, which means we want to find the slope. Which means we want to find derivative. And so A is going to equal 10,000 E 0.075 T. And so the derivative, A prime, is going to be 10,000 times 0.075 E 0.075 T. And so this will be 750 E 0.075 T. And then if I said, okay, T is going to be equal to 1, then this would be 750 E 0.075 times 1, and we get 808.41. Other rules you're going to see in this chapter is you have product rule and quotient rule. So first off, product rule. So if y is equal to f of x times g of x, right? Well, then we're going to want to know what f of x is, and we're going to want to know what is the derivative of that part, and then we're going to have our g of x, and then we want to know the derivative of that part. And so my derivative then is going to be f of x times g prime x plus the derivative of f times g of x. So let's look at an example. So let's say y equals 8x plus 2e to the x times 7x squared plus 2x plus 3. So my f of x is 8x plus 2e to the x. My derivative is going to be 8 2e to the x. And then my g is going to be the 7x squared plus 2x plus 3. And then the derivative of that piece is going to be 14x plus 2. So then my derivative is just put this all together. And so this is going to be 8x, 2e to the x, times 14x plus 2, plus 8 plus 2e to the x, times the 7x squared plus 2x plus 3. And we get that. Well, then, besides that rule, we then also have in here the quotient rule. And so now, y is in the form of f of x over g of x. And again, we want to know what is f of x. We're going to know the derivative of f. We have our g of x, and we want to know the derivative of that. So then my quotient rule is given by this. G of x times f prime x minus f of x, the derivative of g, over g of x squared. Right? So let's do an example of that one. Right? And so let's say we have y equals 6x squared minus 8x over 4x plus 8 ln x. So again, well, the f of x part is going to be the 6x squared minus 8x, and the derivative of that part is going to be 12x minus 8. Okay? And then my bottom piece, g of x, is 4x. 4x. Eraser. 4x. There we go. So 4x plus 8 ln x. And then the derivative of that is going to be 4 plus 8 over x. And then now that we have all our pieces, it's a matter of plugging that all in. And so we get 4x, 8 ln x, times 12x minus 8 minus 6x squared minus 8x times 4 plus 8 over x. All of that divided by the bottom term squared. Right? And we end up at that. Right? All right, so let's look in terms of a business example. And so here we have our formula for total sales, S sub t equals 125 t squared over t squared plus 100. And we want to find the derivative. Well, again, if I take my pieces, okay, we'll say, so we're going to say f is going to be the 125 t squared. F prime is then going to be 250 t. G is going to be t squared plus 100. And then G prime is going to be 2t. So if we plug in, we're going to have t squared plus 100 times 250t minus 125t squared times 2t all over t squared plus 100, the entire thing squared. Well, now in this time, we're going to do some of this stuff out. And so we're going to get 250 t cubed plus 25000 t minus 250 t cubed all over t squared plus 100 squared. And so the top part we can simplify. So this is going to give us 25,000 t over t squared plus 100 squared. So we found our derivative. All right. Oh, let's see other rules we have. We also have in here the thing called the power rule. And so if y is equal to f of x, which we can also write as being u to the x, we'll get what that is in a minute. And then my derivative of u to the n is going to be n times u times u to the n minus 1 du dx. Let's look at an example of how this works. So let's say y equals 4x squared plus 3x plus 7, all of this to the fourth. So my derivative. The way this works is we first take the exponent out front, everything in the parentheses stays the way it is. Drop the exponent by 1. And then we take the derivative of what was inside the parentheses. So this gives me the 8x plus 3. And then here I could do a little simplifying, because I could do the 4 times that 8x plus 3. And so this would give me 32x plus 12 times the 4x squared plus 3x plus 7 cubed. All right. And then the next rule is the chain rule. And so dy dx is going to equal dy du times du dx. So let's look at an example. Let's say y equals e to the x squared plus 3x plus 1. So u is going to be x squared plus 3x plus 1. And then du is going to be 2x plus 3. So this will be my du dx. Right? So my derivative then, y prime, is going to be e to the u, which is going to be x squared plus 3x plus 1, times the derivative, which is going to be the 2x plus 3. And we end up with that. All right. Other things you'll see. So you'll get to this thing called implicit differentiation. Right. So this is what we do when we have a formula where we cannot solve for y. So if I had this, y minus xy squared plus x squared plus 1 equals 0. Well, if I look at that, I can't really just take that equation and solve it for y, all right? So how do I do this? So first off, first one, we're going to take the derivative of everything with respect to x. Okay. So we take the derivative of everything with respect to x, and so we go through, and so the derivative of y with respect to x is going to be dy dx. Okay. But then if I look at my next term, that's x times y squared. Well, that's product rule. So that means this is going to be a minus x. This is going to be a y squared. This is going to be a minus 1. And this will be a 2y dy dx. So I broke it out into my pieces for the product rule, right? So now if I put this in here, this is going to be a minus 2xy dy dx minus y squared. Derivative of x squared is going to be 2x. Derivative of 1 is nothing, and so this is going to equal 0. Right? All right. Right? So we did that. So basically that really is the calculus steps. The rest of this now is algebra steps. So step 2. You want to get dy dx on one side, everything else on the other side. So basically we want to start solving for dy dx. So in this case, what I'm going to do is I'm going to add 2xy. I'm going to right? And I'm going to add the y squared. And I'm going to subtract the 2x. Right? Oops, sorry. Never mind. Oh, sorry. Scratch that. I'm getting ahead of myself. All right. So let me do this. Sorry. So we want to take everything over that doesn't have it, our x, y, our dy dx term in. So I'm going to add y squared. So I'm going to add y squared, and I'm going to subtract 2x. And so we're going to add y squared, and we're going to subtract 2x. Right? So what do we have? So we have dy dx minus 2xy dy dx is going to equal y squared minus 2x. Right? Next thing we're going to do, step 3, factor out dy dx. Right? So when I do that, so dy dx, and so this is going to give me 1 minus 2xy equals y squared minus 2x, right? And then the last thing, step 4, solve for dy dx. So now I'm going to divide 1 minus 2xy. And so we end up that dy dx is going to be y squared minus 2x over 1 minus 2xy. Right? So we found our derivative. So now let's do some more with this. So let's say they gave us some information. So let's say they would say, okay, we want to find the tangent line if x is equal to 1. Okay. So basically we need to know, so if x is 1, we need to know what the y value is. So we go back to our original equation, which was y minus xy squared plus x squared plus 1 equals 0. We know the value of x is 1, so this is going to be y minus y squared plus 1 plus 1. And so we get y minus y squared plus 2 equals 0. And this would be the same thing as y squared minus y minus 2 equals 0. So really I just multiply everything by negative 1. This could be factored. So we're going to get a y minus 2 and a y plus 1. So y minus 2 equals 0, or y plus 1 equals 0. So this will give me 2, and this will give me negative 1. So now we can go through and figure this out. Right? So let's do our first one, which is going to be x equals 1 and y equals 2. So then dy dx, so now we're going to plug in our x and y values, is going to be 2 squared minus 2 times 1 over 1 minus 2 times 1 times 2, which is going to be 2 over 1 minus 4 is going to be a negative 2/3. Right? And then we could also do, so let's do that over here, the other case. And so now we would have x equals 1 and y equals negative 1. And so now dy dx, and so we plug in now, we get negative 1 squared minus 2 times 1 over 1 minus 2 times 1 times negative 1 is a negative 1 over 1 plus 2, so negative 1/3. Right? So now we can find our equations. Right? And so let's just extend this down to separate my cases. And so here we said the slope is negative 2/3. So now we got y minus 2 equals negative 2/3 times x minus 1. And then we can rearrange this into slope-intercept form. So y minus 2 minus 2/3 x plus 2/3. Bring the 2 over. And we end up with y equals minus 2/3 x plus 8/3. Okay? And then if we go to the other side and over here, so now we're going to have y plus 1 negative 1/3 x minus 1. And again, solve this for y. So y plus 1 equals a minus 1/3 x plus 1/3. And then subtract 1. And so we end up with y equals minus 1/3 x minus 2/3. And we have our equations of our tangent line. All right. And next type of questions you'll see are going to be what they call related rates. So let's look at an example of how this works. Let's say the cost function is 500, or actually 5,000 plus 2x. My revenue function is 10x minus 0.001x squared. And then my profit function is given by the revenue function minus the cost function. Right? And then we're given something like this. So we're given that the production increases at a rate of 500 per week. When the production is 2,000. Right. So that what is telling us is that x is 2,000, and the rate of change in x, which is going to be dx dt, is going to be 500. Right? So we want to first find in regards to the cost, what's going on. Well, we had our cost function, which was c of x was equal to 5,000 plus 2x. Right? And so we're going to take the derivative with respect to the time. So dc dt is going to equal 2 times dx dt. And so this is going to be 2 times our rate of change, which is 500. And so this is going to be $1,000 per week. Now, we could also do this now in regards to our revenue. And so revenue function R was 10x minus 0.001x squared. Right? And so again, we can find our derivative. So dr dt is going to be 10 dx dt minus 0.002x dx dt. And again, we can now take our numbers and plug in. So this is going to be 10 times 500 minus 0.002 times 2000 times 500. And so here we get that the revenue is changing at a rate of $3,000 per week. Okay. And then lastly, we get to our profit. Right? Right. And so we said P, so now we can do our profit function. So P was equal to R minus C. So P prime is going to be R prime minus C prime, right? And so the change in profit with respect to time is going to be the change in revenue with respect to time minus the change in the cost with respect to time. And so our numbers, so this was going to be 3,000 minus the 1,000. And so this is going to be $2,000 per week. Right. All right. And then the last thing they talk about in this chapter deals with elasticity of demand. And so E sub P is equal to P times F prime of P over FP. So let's look at this, how this works in terms of, so let's say that X plus 500P equals 10,000. So that would mean that X is going to be 10,000 minus 500P. Right? And so then X prime is going to be a minus 500. Right? So the derivative of X with respect to P. Right? Right? And let's actually relabel that. So this is going to be dx dp. Right? So now we want to find out E sub 4 in my example. E4. So that means P is equal to 4. Right? So E sub 4 is going to be P times my derivative over my original function evaluated when P was 4. Okay. So this is going to come out to be a minus 2,000 over 8,000. So this is going to give us a 0.25. Right? And this will be right. And actually I think that should be a right. Right. Negative in there. All right. That should be a positive number. Right. What do I want? Draw eraser, please. And I think way back on my formula, I forgot there's a negative sign out front. Okay. So there is a negative out front. All right. So let me get that in there, because this should come out to be a positive quantity. All right. So the negative out front is minus and minus, of course, is then going to make this a positive. All right. So we have this minus out front, and that, so that makes it a positive 0.25. Well, what does that tell us about what's going on here? All right. So in the book, they give you this chart. We got E of P, right? And so we got 0, E of P, and then 1. And then we have if EP is greater than 1, and then if EP is equal to 1. Right? And then this tells us something about the demand. So here it's inelastic. Here it's elastic. And here it's unit. And then what does it mean? Interpretation. Well, really this says, this is telling you it's non-sensitive. Here it is sensitive. And then what does this mean in terms of revenue? Well, this tells us that if the price increases, revenue increases. Here, if price increases, then revenue is going to decrease, right? In this situation. Right? So let's look again in terms of my example. So let's say, okay, so my EP is in between those, right? Because ours came out to be 0.25, right? So E of 4 is equal to 0.25, which means inelastic, right? So what would happen? So if the price were to increase by 10%, right? Then the demand will be given by 0.25 times 10%, which is going to be 0.1. And so this will become 0.025. And so the increase would be 2.5% increase in our revenue, right? And that will conclude this video.